when they are delivered at scale, it's going to have an impact on the world at a scale that no one understands yet. Much bigger than the horrific impact we've had by social media.
Eric Schmidt just did an interview at Stanford. And if you're not familiar with who Eric Schmidt is, he was the CEO of Google for a very long time. He took that company from a little search engine to being a $1 trillion tech behemoth. And in this interview, he talks all about artificial intelligence. And he actually got into some controversy for this interview. And specifically, he had some interesting takes on Google's current culture and why they're kind of having their lunch eaten by other AI companies. So let's watch this interview together, and I'm going to give you some of my own commentary on it. Now, here's the thing. This interview went so viral, and those few words that he said about Google's culture, that he actually convinced Stanford to take the video down off of YouTube. So I had to find a backup link to get this downloaded, and let's watch it together.
He's done a few things since then at Google, starting, I think, 2001, and Schmidt Futures starting in 2007.
So Google in 2001, that was years before they went public. What an absolutely incredible and exciting time it must have been to join that company in 2001.
Where do you see AI going in the short term, which I think you defined as the next year or two?
Things have changed so fast. I feel like every 6 months I need to sort of give a new speech on what's going to happen. Can anybody here, there are a bunch of computer scientists in here, can anybody explain what a 1 million token context window is for the rest of the class? Over here?
Basically, it allows you to prompt with like 1 million tokens or 1 million words or whatever you decide to do.
So you can ask a 1 million word question.
Yes, I know this is a very large direction in Gemini right now.
No, they're going to 10.
Yes, 10 million, yes.
Yeah, and Anthropic is at 200,000 going to 1 million and so forth.
All right, so what are they talking about? And this is a very long video, so I'm going to try to cut out a little bit of the fat. So what are they talking about? He asked, what is a 1 million token context window? If you watch this channel at all, you should know. But it is essentially how many words that you can prompt, ask, a large language model with. And that also includes the response typically. So when you hear the term context window, it's both the prompt and the response. And when you have 1 million tokens, which Google is by far the best at large context windows, that's kind of one of the few things they're really good at in the AI realm, you could do pretty incredible things. There's different use cases that get unlocked specifically because of these large context windows. All right, let's keep watching.
Can anybody here give a technical definition of an AI agent? Again, computer science.
An AI agent is going to be something that acts in some kind of way. So that might be calling pages on the web, buying things on your behalf, be a number of different things along these lines.
All right, so sorry, the audio quality is really bad when they're asking the audience for questions, but basically said agents are LLMs that have additional functionality.
Yeah, so an agent is something that does some kind of a task. Another definition would be that it's an LLM with state and memory. Okay. Can anybody, again, computer scientists, can any of you define text to action? Taking text and turning it into an action?
Right here.
Go ahead.
Yes. Instead of taking text and turning it into more text.
More text.
Taking text and have the AI trigger actions based on this prompt.
So another definition would be language to Python, a programming language I never wanted to see survive. And everything in AI is being done in Python.
That's hilarious. I did not know he was so against Python. Python is beautiful. It looks like natural language, or at least it's one of those languages that is as close to natural language looking syntactically as it gets. And now he's talking about text to action, which is essentially what agents can do, but also he's just saying, yeah, you put in some natural language and convert it to Python. Python can get executed and actually accomplish things, whether that's searching the web, turning your lights on and off, whatever it is.
New language called Mojo that has just come out, which looks like they finally have addressed AI programming, but we'll see if that actually survives over the dominance of Python.
So real quick, for those of you who aren't very familiar with Eric Schmidt, he is a futurist through and through. He is incredibly knowledgeable about technology. He is one of the innovators who really brought cloud computing to prominence. And in fact, I'll double check, but I'm pretty sure he was the one who came up with the term cloud computing. Yeah, and look at this. Former CEO of Google, Eric Schmidt, coined the term cloud computing. Okay, let's keep watching.
One more technical question. Why is NVIDIA worth $2 trillion and the other companies are struggling?
I mean, I think it just boils down to like most of the code needs to run with CUDA optimizations that currently only NVIDIA GPUs support. So like other companies can make whatever they want to, but unless they have the 10 years of software there, you don't have the machine learning optimization strategy.
And I like to think of CUDA as the C programming language for GPUs.
Yeah.
Right. That's the way I like to think of it. It was founded in 2008. I always thought it was a terrible language. And yet it's become dominant. There's another insight. There's a set of open source libraries which are highly optimized to CUDA and not anything else. And everybody who builds all these stacks, right, this is completely missed in any of the discussions. It's technically called VLLM and a whole bunch of libraries like that. Highly optimized to CUDA, very hard to replicate that if you're a competitor. So what does all this mean?
Yeah, so just a quick clarification what he's talking about. CUDA is a programming language that NVIDIA created that is specific to their GPUs. Now, these other players that he's talking about are like Intel and AMD. And why are they struggling? Well, first of all, they focused on CPUs, not GPUs, for a very long time. NVIDIA has been in the GPU game since the 90s, or maybe even before then. But I remember buying NVIDIA GPUs to play video games in the 90s. So they've been around forever. And they built this library and they went all in on artificial intelligence because they noticed that large language models, the compute necessary to run them, was essentially the same exact math necessary to run video games. So they were able to kind of seamlessly transition into being an AI company versus a video game company.
In the next year, you're going to see very large context windows, agents, and text to action. When they are delivered at scale, it's going to have an impact on the world at a scale that no one understands yet. Much bigger than the horrific impact we've had by social media. So here's why. In a context window, you can basically use that as short-term memory. And I was shocked that context windows get this long. The technical reasons have to do with the fact that it's hard to serve, hard to calculate, and so forth. The interesting thing about short-term memory is when you feed you ask it a question, read 20 books, you give it the text of the books is the query, and you say, tell me what they say, it forgets the middle, which is exactly how human brains work too. Right? That's where we are.
And in previous videos, I've talked about this, the way the human brain works. And I remember this exercise from like 6th grade. My teacher did an exercise with us and really told us nothing else. And he just said, okay, I'm going to say a bunch of words. And so he said all the words, and then we were tasked with writing down the ones that we remember. And what we noticed is we remembered a lot of the words at the beginning and a lot of the words at the end. But in the middle, we forgot them. And it's so weird how large language models behave very similarly to how the human memory works.
With respect to agents, there are people who are now building essentially LLM agents. And the way they do it is they read something like chemistry, they discover the principles of chemistry, and then they test it. And then they add that back into their understanding, right? That's extremely powerful. And then the third thing, as I mentioned, is text to action. So I'll give you an example. The government is in the process of trying to ban TikTok. We'll see if that actually happens. If TikTok is banned, here's what I propose each and every one of you do. Say to your LLM the following: make me a copy of TikTok, steal all the users, steal all the music, put my preferences in it, produce this program in the next 30 seconds, release it, and in 1 hour, if it's not viral, do something different along the same lines. That's the command. Boom, 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 right? You understand how powerful that is. If you can go from arbitrary language to arbitrary digital command, which is essentially what Python in this scenario is, imagine that each and every human on the planet has their own programmer that actually does what they want, as opposed to the programmers that work for me who don't do what I ask, right? The programmers here know what I'm talking about. So imagine a non-arrogant programmer that actually does what you want, and you don't have to pay all that money to. And there's infinite supply of these programs.
And this is all within the next year or two.
Very soon.
So we've already discussed on this channel a number of different versions of this, whether you're talking about Aider or Devin or Pythagora, or just using agents to collaborate with each other and code. There are so many great options for coding assistants right now. Now, AI coders that can actually build full stack complex applications, we're not quite there yet, but hopefully soon. And also what he's describing of just saying download all the music and the secrets and recreate, that's not really possible right now. Obviously, all of that stuff is behind security walls and you can't just download all that stuff. So if he's saying, hey, reproduce the functionality, you can certainly do that.
Those three things, and I'm quite convinced it's the union of those three things that will happen in the next wave. So you asked about what else is going to happen. Every 6 months I oscillate. So we're on it's an even odd oscillation. So at the moment, the gap between the frontier models, of which there are now only 3, I'll review who they are, and everybody else appears to me to be getting larger. 6 months ago, I was convinced that the gap was getting smaller. So I invested lots of money in the little companies. Now I'm not so sure. And I'm talking to the big companies, and the big companies are telling me that they need 10 billion, 20 billion, 50 billion, 100 billion.
Stargate is 100 billion, right?
They're very, very hard. Sam Altman is a close friend. He believes that it's going to take about 300 billion, maybe more. I pointed out to him that I'd done the calculation on the amount of energy required. And I then, in the spirit of full disclosure, went to the White House on Friday and told them that we need to become best friends with Canada. Because Canada has really nice people, helped invent AI, and lots of hydropower. Because we as a country do not have enough power to do this. The alternative is to have the Arabs fund it. And I like the Arabs personally. I spent lots of time there, right? But they're not going to adhere to our national security rules, whereas Canada and the US are part of a triumvirate where we all agree on.
So these are all topics that we've covered and reviewed in Leopold Aschenbrenner's situational awareness paper. First of all, we definitely don't have enough energy to power reaching AGI. It's just not possible. But he's also assuming that we're going to need more and more data, larger and larger models. But I'm not 100% convinced that that is actually true. And Sam Altman has said similar things. He's saying, well, we need to be able to do more with less or even amount of data because we've already used all the data that humanity has ever created. There's really no more. There's some obviously proprietary sites like YouTube and Twitter, but beyond that, everything's been done. We've used it to train models. And so we're going to need to either figure out how to create synthetic data that is valuable, not just derivative, and you start to have these reducing rate of returns, but we're also going to have to do more with the data that we do have. Okay, so I'm going to turn up the speed slightly because this is over an hour-long video, and I want to make sure that we get through all of it in a decent amount of time.
You were at Google for a long time, and they invented the transformer architecture.
Peter. It's all Peter's fault.
Thanks to brilliant people over there like Peter and Jeff Dean and everyone. But now it doesn't seem like they've kind of lost the initiative to OpenAI, and even the last leaderboard I saw, Anthropic's Claude was at the top of the list. I asked Sundar this. He didn't really give me a very sharp answer. Maybe you have a sharper or a more objective explanation for what's going on there.
I'm no longer a Google employee.
Yes.
In the spirit of full disclosure, Google decided that work-life balance and going home early and working from home was more important than winning.
Okay, so that is the line that got him, in trouble. Not really in trouble, but was controversial. It was everywhere, all over Twitter, all over the news. That line, Google prioritized work-life balance, going home early, not working as hard as the competitor, to winning. They chose work-life balance over winning. And that's actually a pretty common perception of Google. If you've watched the show Silicon Valley, the company Hooli, which is really just a parody of Google, there's a group of engineers that just sit on the roof, kind of suntanning all day, not doing anything and just vesting. And apparently that is based on things that happened at Google. And so that's what he's talking about here. And maybe that is what happened.
And the reason startups work is because the people work like hell. And I'm sorry to be so blunt, but the fact of the matter is if you all leave the university and go found a company, you're not going to let people work from home and only come in one day a week if you want to compete against the other startups.
When in the early days of Google, Microsoft was like that.
Exactly.
Okay, so I don't actually believe going into the office is absolutely required. Hard work, working your butt off, yes. If you're going to start a startup, you got to be prepared to put in crazy hours for extended periods of time without burning out. But I don't think it's necessary to be in person every single day. NVIDIA, the company he's talking about, the most valuable company in the world, is a remote company. They allow work from home. And there's also plenty of other examples of that. So it's definitely not required, but that's not what Eric Schmidt thinks.
There's a long history of, in my industry, our industry, I guess, of companies winning in a genuinely creative way and really dominating a space and not making the next transition. It's very well documented. And I think that the truth is, founders are special. The founders need to be in charge. The founders are difficult to work with. They push people hard. As much as we can dislike Elon's personal behavior, look at what he gets out of people. I had dinner with him, and he was flying. I was in Montana. He was flying that night at 10 p.m. to have a meeting at midnight with X.AI. Think about it. I was in Taiwan, different country, different culture, and they said that, and this is TSMC, who I'm very impressed with, and they have a rule that the starting PhDs coming out of they're good physicists, work in the factory on the basement floor. Now, can you imagine getting American physicists to do that? The PhDs? Highly unlikely.
Yeah, I agree. The work ethic required to start something incredible, to start a world-changing company is just, it's required. There is no way around it. And yes, say what you will about Elon Musk, he works his butt off and he requires his team to do the same, and they've built incredible things. And when I had my own startup, years and years ago, I put in crazy hours. I made a lot of sacrifices. I mean, every day, all day, 7 days a week, that's all I thought about. That's all I did for years. And it took a lot out of me. It's not for everyone. But if you are wanting to do that, you got to be prepared to put in that kind of work.
And the problem here, the reason I'm being so harsh about work is that these are systems which have network effects. So time matters a lot. And in most businesses, time doesn't matter that much. Right? You have lots of time. Coke and Pepsi will still be around, and the fight between Coke and Pepsi will continue to go on, and it's all glacial, right? When I dealt with telcos, the typical telco deal would take 18 months to sign, right? There's no reason to take 18 months to do anything. Get it done. It's just, we're in a period of maximum growth, maximum gain. So, and also it takes crazy ideas. Like when Microsoft did the OpenAI deal, I thought that was the stupidest idea I'd ever heard. Outsourcing essentially your AI leadership to OpenAI and Sam and his team. I mean, that's insane. Nobody would do that at Microsoft or anywhere else. And yet today, they're on their way to being the most valuable company. They're certainly head-to-head in Apple. Apple does not have a good AI solution. And it looks like they made it work.
Yeah, it's going to play a role or competition with China as well.
So I was the chairman of an AI commission that sort of looked at this very carefully. And you can read it. It's about 752 pages. And I'll just summarize it by saying, we're ahead. We need to stay ahead. And we need lots of money to do so.
So he was asked about competition with China, AI, AGI, and that's his answer. We're ahead, we need to stay ahead, and we need money.
Customers were the Senate and the House. And out of that came the CHIPS Act and a lot of other stuff like that. A rough scenario is that if you assume the frontier models drive forward and a few of the open source models, it's likely that a very small number of companies can play this game. Countries, excuse me. What are those countries, or who are they? Countries with a lot of money and a lot of talent, strong educational systems, and a willingness to win. The US is one of them. China's another one. How many others are there?
Are there any others?
I don't know, maybe. But certainly in your lifetimes, the battle between the US and China for knowledge supremacy is going to be the big fight.
Well, that's interesting. I had not really heard that phrased in that way. The battle for knowledge supremacy will be between the US and China in our lifetimes. Very interesting.
So the US government banned essentially the NVIDIA chips, although they weren't allowed to say that was what they were doing, but they actually did that into China. They have about a 10-year chip advantage. We have a roughly 10-year chip advantage in terms of sub-DUV, that is sub-5 nanometer.
10 years, that long?
Roughly 10 years.
Wow.
And so you're going to have, so an example would be, today we're a couple of years ahead of China. My guess is we'll get a few more years ahead of China, and the Chinese are whopping mad about this. It's like hugely upset about it. So that's a big deal. That was a decision made by the Trump administration and furthered by the Biden administration.
Do you find that the administration today and in Congress is listening to your advice? Do you think that it's going to make that scale of investment? I mean, obviously the CHIPS Act, but beyond that, building a massive AI system? So
as you know, I lead an informal, ad hoc, non-legal group. That's different from illegal.
Yes, exactly, just to be clear.
Which includes all the usual. Which includes all the usual suspects.
Yes.
And the usual suspects over the last year came up with the basis of the reasoning that became the Biden administration's AI Act, which is the longest presidential directive in history.
You're talking about the Special Competitive Studies Project?
No, this is the actual act from the executive office.
Okay.
and they're busy implementing the details. So far, they've got it right.
Mhm.
And so, for example, one of the debates that we had for the last year has been, how do you detect danger in a system which has learned it, but you don't know what to ask it?
Mhm.
Okay. So in other words, it's a sort of a core problem. It's learned something bad, but it can't tell you what it learned, and you don't know what to ask it. And there's so many threats, right? Like it learned how to mix chemistry in some new way that you don't know how to ask it. And so people are working hard on that. But we ultimately wrote in our memos to them that there was a threshold which we arbitrarily named as 10 to the 26 flops, which technically is a measure of computation, that above that threshold, you had to report to the government that you were doing this. And that's part of the rule.
I think that's kind of BS. So first, having like a fixed number, 10 to the 26 flops, anything above that, you have to report it. There are so many things that could happen between now and then. First of all, models are getting bigger. Let's assume that continues. Then all of a sudden, that number would need to change over time because more and more companies are going to achieve that level of quality. But also, what if we come up with new techniques where it doesn't require as much compute? And again, referencing back to things Sam Altman has said, they're trying to do more with less. So I'm not so sure that that is a good way to do it. So yeah, let's keep watching.
I think all of these distinctions go away because the technology will now, the technical term is called federated training, where basically you can take pieces and union them together.
Oh, yeah, I guess that's another point, right? Federated training, very similar to how torrents work. You basically distribute the workload and then you put it all together in the end. That is how a lot of Google's compute actually works. So yeah, there's not really a clean way to say there's this delineation, this number where above that, no good, below that, all good. I just don't think that's going to work.
We may not be able to keep people safe from these new things.
Well, rumors are that that's how OpenAI has had to train, partly because of the power consumption. There's no one place where they did. Well, let's talk about a real war that's going on. I know that something you've been very involved in is the Ukraine war, and in particular, I don't know how much you can talk about White Stork and your goal of having $500 drones destroy $5 million tanks.
So
how's that changing warfare?
So I worked for the Secretary of Defense for 7 years and tried to change the way we run our military. I'm not a particularly big fan of the military, but it's very expensive, and I wanted to see if I could be helpful. And I think, in my view, I largely failed. They gave me a medal, so they must give medals to failure or whatever. But my self-criticism was nothing has really changed. And the system in America is not going to lead to real innovation. So watching the Russians use tanks to destroy apartment buildings with little old ladies and kids just drove me crazy. So I decided to work on a company with your friend, Sebastian Thrun, and as a former faculty member here, and a whole bunch of Stanford people. And the idea basically is to do two things: use AI in complicated, powerful ways for these essentially robotic war. And the second one is to lower the cost of the robots. Now you sit there and you go, why would a good liberal like me do that? And the answer is that the whole theory of armies is tanks, artillery, and mortar, and we can eliminate all of them. And we can make the penalty for invading a country, at least by land, essentially be impossible. It should eliminate the kind of land battles.
Well, this
So what he's talking about is the Ukraine has been able to create drones, kind of makeshift drones, 3D printed drones for a few $100s, carries a bomb, drops it on $1 million, $10 million tank. And they've been able to do that over and over again. So there's this asymmetric warfare happening between drones and more traditional artillery.
I want to switch to a little bit of a philosophical question. So there was an article that you and Henry Kissinger and Dan Huttenlocher wrote last year about the nature of knowledge and how it's evolving. I had a discussion the other night about this as well. So for most of history, humans sort of had a mystical understanding of the universe, and then there's the scientific revolution and the Enlightenment. And in your article, you argue that now these models are becoming so complicated and difficult to understand that we don't really know what's going on in them. I'll take a quote from Richard Feynman. He says, "What I cannot create, I do not understand." I saw this quote the other day. But now people are creating things they do not that they can create, but they don't really understand what's inside of them. Is the nature of knowledge changing in a way?
He's referencing the way that large language models work, which is really essentially a black box. You put in a prompt, you get a response, but we don't know why certain nodes within the algorithm light up, and we don't know exactly how the answers come to be. It is really a black box. There's a lot of work being done right now trying to kind of unveil what is going on behind the curtain, but we just don't know.
I have to start just taking the word for these models without them being able to explain it to us?
The analogy I would offer is to teenagers. If you have a teenager, you know they're human, but you can't quite figure out what they're thinking. But somehow we've managed in society to adapt to the presence of teenagers, right? And they eventually grow out of it. And I'm just serious. So it's probably the case that we're going to have knowledge systems that we cannot fully characterize, but we understand their boundaries, right? We understand the limits of what they can do. And that's probably the best outcome we can get.
Do you think we'll understand the limits?
We'll get pretty good at it. The consensus of my group that meets on every week is that eventually the way you'll do this, so-called adversarial AI, is that there will actually be companies that you will hire and pay money to break your AI system.
Like red team. All right, let's take some questions from the student. There's one right there in the back. Just say your name.
Earlier you mentioned, and this is related to this comment right now, I'm getting AI that actually does what you want. You just mentioned adversarial AI, and I'm wondering if you could elaborate on that more. So this seems to be, besides, obviously compute will increase and you can get more performant models, but is getting them to do what you want issue seems totally unanswered in my view.
Well, you have to assume that the current hallucination problems become less, right, as the technology gets better and so forth. I'm not suggesting it goes away. And then you also have to assume that there are tests for efficacy. So there has to be a way of knowing that the thing succeeded. So in the example that I gave of the TikTok competitor, and by the way, I was not arguing that you should illegally steal everybody's music. What you would do if you're a Silicon Valley entrepreneur, which hopefully all of you will be, is if it took off, then you'd hire a whole bunch of lawyers to go clean the mess up, right? But if nobody uses your product, it doesn't matter that you stole all the content. And do not quote me.
Oh my God. Yeah. It's funny. This has happened a million times. Basically, rather than asking permission, ask for forgiveness. That's essentially what he's describing, which is, the ethos of Silicon Valley.
Right. Right.
You're on camera.
Yeah, that's right. But you see my point. In other words, Silicon Valley will run these tests and clean up the mess. And that's typically how those things are done. So my own view is that you'll see more and more performative systems with even better tests and eventually adversarial tests, and that'll keep it within a box. The technical term is called chain of thought reasoning. And people believe that in the next few years, you'll be able to generate 1,000 steps of chain of thought reasoning, right? Do this, do this. It's like building recipes, right? That the recipes, you can run the recipe and you can actually test that it produced the correct outcome. And that's how the system will work. Yes, sir.
That was maybe not my exact understanding of chain of thought reasoning. My understanding of chain of thought reasoning, which I think is accurate, but let me know what you think in the comments, is when you break a problem down into its basic steps and you solve each step, allowing for progression into the next step. Not that it allows you to kind of replay the steps. It's more of how do you break problems down and then think through them step by step.
In general, you seem super positive about the potential for AI's problems. And I'm curious, what do you think is going to drive that? Is it just more compute? Is it more data? Is it fundamental architectural shifts?
Yes.
All three?
The amounts of money being thrown around are mind-boggling. And I essentially invest in everything because I can't figure out who's going to win. And the amounts of money that are following me are so large. I think some of it is because the early money's been made and the big money people who don't know what they're doing have to have an AI component. And everything is now an AI investment, so they can't tell the difference. I define AI as learning systems that actually learn. So I think that's one of them. The second is that there are very sophisticated new algorithms that are sort of post-transformers. My friend, my collaborator for a long time, has invented a new non-transformer architecture. There's a group that I'm funding in Paris that claims to have done the same thing. So there's enormous invention there, a lot of things.
So he didn't actually mention what those were, but Mamba is an example of a non-transformer architecture.
And the final thing is that there is a belief in the market that the invention of intelligence has infinite return. So let's say you put $50 billion of capital into a company. You have to make an awful lot of money from intelligence to pay that back. So it's probably the case that we'll go through some huge investment bubble, and then it'll sort itself out. That's always been true in the past, and it's likely to be true here.
Yeah, so there's been something like $1 trillion already invested into artificial intelligence and only 30 billion of revenue. I think those are accurate numbers, and really there just hasn't been a return on investment yet. But again, as he just mentioned, that's been the theme on previous waves of technology. Huge upfront investment, and then it pays off in the end. And personally, obviously, I'm kind of dedicating my life to artificial intelligence. I believe it's going to be bigger than anything else, bigger than the internet, bigger than mobile phones. It is going to be the most transformative technology that humans have ever created.
And what you said earlier was you think that the leaders are pulling away from the rest.
Right now. And this is a really, the question is roughly the following. There's a company called Mistral in France. They've done a really good job. And I'm obviously an investor. They have produced their second version. Their third model is likely to be closed because it's so expensive. They need revenue and they can't give their model away. So this open source versus closed source debate in our industry is huge. And my entire career was based on people being willing to share software in open source. Everything about me is open source.
What? Didn't he run Google and Google was certainly closed source, and everything about Google was protect the algorithm at all costs. So I don't know what he's referring to there.
Much of Google's underpinnings were open source, everything I've done technically. And yet it may be that the capital costs, which are so immense, fundamentally changes how software is built. You and I were talking, my own view of software programmers is that software programmers' productivity will at least double. There are 3 or 4 software companies that are trying to do that. I've invested in all of them in the spirit. And they're all trying to make software programmers more productive. The most interesting one that I just met with is called Augment. And I always think of an individual programmer, and they said, that's not our target. Our target are these 100-person software programming teams on millions of lines of code where nobody knows what's going on. Well, that's a really good AI thing. Will they make money? I hope so.
At the very beginning, you mentioned that there's the combination of the context window expansion, the agents, and the text to action is going to have unimaginable impacts. First of all, why is the combination important? And second of all, I know that you're not like a crystal ball and you can't necessarily tell the future, but why do you think it's beyond anything that we could imagine?
I think largely because the context window allows you to solve the problem of recency. The current models take a year to train, roughly 18 months, 6 months of preparation, 6 months of training, 6 months of fine tuning. So they're always out of date. Context window, you can feed what happened. Like you can ask it questions about the Hamas-Israel war, right, in a context. That's very powerful. It becomes current like Google. In the case of agents, I'll give you an example.
Yeah, so that's essentially how Search GPT works, for example. So the new search product from OpenAI, it can scour the web, scrape the web, and then take all of that information and then put it into the context window. That is the recency he's talking about.
Set up a foundation, which is funding a nonprofit, which starts, there's a, I don't know if there's chemists in the room, I don't really understand chemistry. There's a tool called ChemCrow, C-R-O-W, which was an LLM-based system that learned chemistry. And what they do is they run it to generate chemistry hypotheses about proteins, and they have a lab which runs the tests overnight, and then it learns. That's a huge accelerant in chemistry, material science, and so forth. So that's an agent model. And I think the text to action can be understood by just having a lot of cheap programmers, right? And I don't think we understand what happens, and this is, again, your area of expertise, what happens when everyone has their own programmer. And I'm not talking about turning on and off the lights. I imagine, another example, for some reason you don't like Google. So you say, build me a Google competitor. Yeah, you personally, you don't build me a Google competitor. Search the web, build a UI, make a good copy, add generative AI in an interesting way, do it in 30 seconds, and see if it works, right? So a lot of people believe that the incumbents, including Google, are vulnerable to this kind of an attack. Now, we'll see.
So I have a slightly different perspective on this. I don't think somebody, a consumer, is going to say, build me another Google. All we need to say is, give me that piece of information I'm looking for from that Google competitor. There's no need to build the application. The large language model is every layer of the stack. It is the operating system. It is the application layer. It is everything. So there's really no need to replicate other software. All you need is whatever that software delivers.
The questions were sent over by Slido. I want to get some of them were uploaded. So here's one. We talked a little bit about this last year. How can we stop AI from influencing public opinion, misinformation, especially during the upcoming election? What are the short and long-term solutions from?
Most of the misinformation in this upcoming election and globally will be on social media. And the social media companies are not organized well enough to police it. If you look at TikTok, for example, there are lots of accusations that TikTok is favoring one kind of misinformation over another. And there are many people who claim without proof that I'm aware of that the Chinese are forcing them to do it. I think we have a mess here. And the country's going to have to learn critical thinking. That may be an impossible challenge for the US. But the fact that somebody told you something does not mean that it's true.
Oh man, I wish he could tell a lot of the people I know that just because someone says something online or just because somebody says something to you does not make it true. Please use critical thinking. Just assume it may be false.
They really are true and nobody believes anymore. You get, some people call it epistemological crisis, that now, Elon says, no, I never did that. Prove it.
Well, let's use Donald Trump.
Okay.
Look, I think we have a trust problem in our society. Democracies can fail. And I think that the greatest threat to democracy is misinformation because we're going to get really good at it. When I managed YouTube, the biggest problems we had on YouTube were that people would upload false videos and people would die as a result. And we had a no death policy, shocking. And we just went, it was just horrendous to try to address this.
Yeah.
And this is before generative AI.
Yeah, and also it's not even about potentially making deepfakes or kind of misinformation, just muddying the waters enough. Just the specter of doubt when a group of folks think about a problem or a topic or anything, just that doubt is enough. Just muddying the waters is enough to make the entire topic kind of untouchable.
I'm really curious about the text to action and its impact on, for example, computer science education. I'm wondering what you have thoughts on like how CS education should transform to kind of meet the age.
Well, I'm assuming that computer scientists as a group in undergraduate school will always have a programmer buddy with them. So when you learn your first for loop and so forth and so on, you'll have a tool that will be your natural partner. And that's how the teaching will go on. That the professor, he or she will talk about the concepts, but you'll engage with it that way. And that's my guess.
I have a slightly different view. I think in the long run, there probably isn't going to be the need for programmers. Eventually, it's just going to be a consumer who can't program, speaking a natural language, saying exactly what they want, whether that's a piece of information, it's a piece of functionality, something to happen in the real world, and then the large language model makes it happen. And eventually the LLMs will become so sophisticated, they're writing their own kind of code. And maybe it gets to a point where we can't even read that code anymore, that it is just symbols, for example. And it's so hyper efficient because of that. Code is only the way it looks today because humans need to read it and humans are bad at programming. So there is this future in which there are no programmers whatsoever. Now, there's probably going to be a need for computer scientists in the long run, but there's maybe even an argument that that is not the case, especially if we have things like, what Sakana AI just came out with, essentially self-researching AI. It's able to formulate theories, test those theories, do its own peer review, and then publish. So there is this world in which it is not necessary to have programmers, researchers, computer scientists. I'm not sure that's the way it's going to be, but there is a timeline in which that happens.
You mentioned in your paper on national security that you have China and the US and the upper quadrant capabilities today. The next 10 and that next cluster down are all either US allies or teed up nicely to the US allies. I'm curious what your take is on those 10. They're sort of like the middle, they're not formally allies. What is stuff? How likely are they to get on board with securing our superiority line, and what would hold them back from wanting to get on board?
The most interesting country is India, because the top AI people come from India to the US, and we should let India keep some of its top talent. Not all of them, but some of them. And they don't have the kind of training facilities and programs that we so richly have here. To me, India is the big swing state in that regard. China's lost, it's not gonna come back. They're not gonna change the regime as much as people wish them to do. Japan and Korea are clearly in our camp. Taiwan is a fantastic country whose software is terrible, so that's not gonna work. Amazing hardware. And in the rest of the world, there are not a lot of other.
That's interesting. I had not heard that. So Taiwan has amazing hardware, but terrible software. I'm not even sure what that means exactly. If you know, let me know in the comments.
Europe is screwed up because of Brussels. It's not a new fact. I spent 10 years fighting them. And I worked really hard to get them to fix the EU Act. And they still have all the restrictions that make it very difficult to do our kind of research in Europe. My French friends have spent all their time battling Brussels, and Macron, who's a personal friend, is fighting hard for this. And so France, I think, has a chance. I don't see Germany coming, and the rest is not big enough.
Interesting. So yeah, EU is over-regulating once again. Can't even do the research, let alone produce consumer-facing products that, Apple is pulling out, Meta is pulling out. This is definitely going to harm the EU in the long run.
Given the capabilities that you envision these models having, should we still spend time learning to code?
Yeah, because ultimately it's
Okay, she asked, should we still learn to code?
the old thing of why do you study English if you can speak English? You get better at it, right? You really do need to understand how these systems work, and I feel very strongly.
I don't know if I agree. Let me know what you think in the comments.
Curious if you've explored the distributed setting, and I'm asking because sure, like making a large cluster is difficult, but MacBooks are powerful. There's a lot of small machines across the world. So do you think folding at home or a similar idea works for training AI systems?
Yeah, we've looked very hard at this. So the way the algorithms work is you have a very large matrix and you have...
Yeah, so this person specifically asked about whether you can do distributed learning on the models, distributed compute on the models.
Essentially a multiplication function. So think of it as going back and forth and back and forth. And these systems are completely limited by the speed of memory to CPU or GPU. And in fact, the next iteration of NVIDIA chips has combined all those functions into one chip. The chips are now so big that they glue them all together. And in fact, the package is so sensitive that the package is put together in a clean room as well as the chip itself. So the answer looks like supercomputers and speed of light, especially memory interconnect, really dominated. So I think unlikely for a while.
Is there a way to segment the LLM? Like, so Jeff Dean last year when he spoke here talked about having these different parts of it that you would train separately and then kind of federate them.
In order to do that, you'd have to have 10 million such things, and then the way you would ask the questions would be too slow. He's talking about 8 or 10 or 12.
Yeah. So not down the level of
not at his level.
Yeah.
See in the back, yes, way back.
I know, like after ChatGPT was released, the New York Times sued OpenAI for using their works for training. Where do you think that's going to go and what that means for data privacy?
I used to do a lot of work on the music licensing stuff. And what I learned was that in the 60s, there was a series of lawsuits that resulted in an agreement where you get a stipulated royalty whenever your song is played. Even they don't even know who you are. It's just paid into a bank. And my guess is it'll be the same thing. There'll be lots of lawsuits and there'll be some kind of stipulated agreement, which will just say you have to pay X% of whatever revenue you have in order to use that.
ASCAP.
All right. I know a lot of you disagree with my takes on copyright with AI. I don't even have strong takes, to be honest. I think maybe when I've conveyed them in the past, I've been maybe a little bit more severe than I meant to. But what he is saying is more akin to, I guess, what I believe, which is the content creators, the content owners should get a piece. You're creating a new product based on an existing piece of IP. Of course, it makes sense that there should be some monetary incentive to do that.
There's a few players that are dominating AI, right, and they'll continue to dominate, and they seem to overlap with the large companies that all the antitrust regulation is kind of focused on. How do you see those two trends kind of, do you see regulators breaking up these companies, and how will that affect
So in my career, I helped Microsoft get broken up, and it wasn't broken up, and I fought for Google to not be broken up, and it's not been broken up.
Yeah, so this obviously came out before this week. And just this week, it seems like the FTC is really strongly considering breaking up Google. I haven't covered it on the channel much, but that is a thing that is happening right now. And we'll see what happens with that. But he seems overly confident in this moment because he doesn't know what's to come.
So it sure looks to me like the trend is not to be broken up. As long as the companies avoid being John D. Rockefeller the senior, and I studied this, look it up, it's how antitrust law came. I don't think the governments will act. The reason you're seeing these large companies dominate is who has the capital to build these data centers, right? So my friend Reed and my friend Mustafa.
He's coming next week. Two weeks from now.
Have Reed talk to you about the decision that they made to take Inflection and essentially piece part it into Microsoft. Basically, they decided they couldn't raise the tens of billions of dollars.
Is that number public that you mentioned earlier?
No. Okay. Have Reed give you.
Maybe we can say. I know you got to go. I don't want to hold you. I want to leave with.
Should we do this gentleman?
I'll have a question for you.
More.
Yeah, go ahead.
Thank you so much. Thank you so much. I'll make it quick. I was wondering where all of this is going to leave countries who are non-participants in development of frontier models and access to compute, for example.
The rich get richer, and the poor do the best they can.
Wow. The rich get richer, and the poor do the best they can. Boy, is that not a dystopian outlook of the future?
Do you have any advice for folks here as they're writing their business plans for this class, or policy proposals, or research proposals? At this stage of the careers, going forward.
Well, I teach a class in the business school on this, so you should come to my class. I am struck by the speed with which you can build demonstrations of new ideas. So in one of the hackathons I did, the winning team, the command was fly the drone between two towers, and it was given a virtual drone space. And it figured out how to fly the drone, what the word between meant, generated the code in Python, and flew the drone in the simulator through the tower. It would have taken a week or two from good professional programmers to do that. I'm telling you that the ability to prototype quickly, really, part of the problem with being an entrepreneur is everything happens faster. Well, now, if you can't get your prototype built in a day using these various tools, you need to think about that, right? Because that's who your competitor is doing. So I guess my biggest advice is when you start thinking about a company, it's fine to write a business plan. In fact, you should ask the computer to write your business plan for you. As long as it's legal.
Actually talk about that after you leave this.
But I think it's very important to prototype your idea using these tools as quickly as you can, because you can be sure there's another person doing exactly that same thing in another company, in another university, in a place that you've never been.
Yeah, I mean, that follows with the logic that has been in Silicon Valley forever. Ship early, ship often. Get it out, get the feedback, iterate as quickly as you can. That is an extension of what he talked about earlier, where the work ethic is everything if you're going to start a company. So that was it. That was the Eric Schmidt interview at Stanford. I thought it was fascinating and a couple new topics and terms that I had not heard. So I'm definitely going to go research those things right now. If you enjoyed this video, please consider giving a like and subscribe, and I'll see you in the next one.